Hello friends, welcome to my YouTube channel. Today friends I am going to discuss about thread synchronization, why the synchronization is required, what is thread critical section, what is critical section and why we need to save the critical section, what is mutex, semaphore and the deadlock. So all this I am going to discuss in details with example today. So let's start friends. So here I have already uploaded few more videos related to C, C++, and here is the thread related video that I have uploaded earlier. So please go through this video to understand get a deep understanding of thread, why thread is required. So next, once that you understand the thread, then you have to understand what is mutex, semaphore and why synchronization is required. So another video I have uploaded here. Uh, so this hash map related video also I recommend you to check before viewing this video because these two examples I am using right now. So let's start friends. So so before understanding the synchronization, let's first understand what is critical section. So uh, So every process has a reserved segment of code which is known as critical section. That means every process has some part of code which is used by multiple threads. Now what is thread and all this I have already uploaded another video, so you go through that first. So I am just discussing the theory then with an example right now. So every process has a part of code which is used by multiple threads, and that part is called the critical section, where you have some global variables or you have to use some shared resources are there. So that part is called the critical section of the process. Now let's see an example here. So this is the example that I have earlier discussed in my thread video. So this is just continuation of this that video, that program. So what I have added here extra is I have added the map example, the hash map example here, which I have discussed in another video, hash map video. So I you check those videos first, so you will get a clear understanding what this function and all this means. So here I have one multi hash map already defined. So here I am just doing an insert record to hash map, remove record from an hash map, and this insertion I am doing from a thread. So just go through my earlier video so you will understand what these functions are used for. So here I have created one thread. From this thread I am just inserting the record and removing the record. So I will start multiple threads here, like here I have started multiple threads, and multiple threads will try to insert record and remove record from that hash map. So now this insert function, what critical section is, this is what I am trying to explain here. So this insert record has an employee record. So this employee is a global variable. See, this is a global variable. Now if five threads are accessing this, when I will call this insert record from different threads, so these different threads can access this function at the same time. So this is the critical part of the program. This is what is called the critical section of the process. So when multiple threads will access a shared resource that we need to, this is the critical section. Here I am inserting one record. So you might have heard about booking system, ticket booking system and all this, where people mentioned about, you've seen multiple examples like ticket booking system where you have to lock the resource before booking the ticket. So once this is locked, another person cannot access that ticket until it is released. So this is the critical section. Here also I am inserting the record in a record in an employee record. So this is a critical section for me. So when I am inserting this record, no one else shall be able to uh, access that part. So this is what is critical section. So this is what is critical section. Now let's understand what is synchronization. So now if 10 threads trying to access a critical section, so at a time one thread will be able to access that part, other threads will be waiting, other threads or process will be waiting to acquire that resource. This is called synchronization. And why synchronization is required? As I explained earlier, like a ticket booking system, you take an example where uh, same ticket multiple person cannot book, one person can book one ticket at a time. So until the ticket is booked or released, next person cannot access the ticket. So this is one example. But in C++, there are multiple reasons why we need synchronization. Like we have a shared resource like this, and if I there can be some dynamic memory allocated variable also, which is a global dynamic variable. So if you want to access a resource, you cannot allow multiple person to access the same memory, multiple threads to access the same memory. You have to lock that part. So that is why the synchronization is required. This is what is called synchronization. So now let's see. Now we understood the synchronization and critical section. Now let's see what is how the critical section we can lock. What are the various process how to synchronize a critical section, access critical section. So there are basically two ways. One is called mutex, another is called semaphore. So mutex itself is a single locking system. So Mutex is mutual exclusion object for synchronizes access to resource. It is created with a unique name and start a program. The mutex is a locking mechanism that makes sure only one thread can acquire the mutex at a time and enter the critical section. This thread only releases the mutex when it exits the critical section. So here the critical section, when a thread acquires a mutex lock. So I will be showing this example here. This one is a mutex example I will be showing here. So what that mutex is means, the thread will acquire the mutex. The thread that will acquire the mutex, it has to release the thread. So it's a single at one time single thread can access the resource. So once it release, next thread can uh, acquire the critical section. But in mutex, this is mutex. So let's see an example here. So here is an example of mutex critical section. Now, if you search in Google, you will find how the mutex works. The POSIX mutex I am going to discuss here. So here I am showing you an example how to create. So what are the various uh, So here is a thread. Pthread provides the mutex function. So what you have to do is these are libraries, mutex libraries critical. Uh, so here pthread mutex init. This you have to do to acquire the mutex. Then you have to then you can acquire the lock and you can do the unlock. So these are the three functions basically useful for pthread mutex. So you have to initialize the mutex with the critical. So here I have created a class. Uh, so here you can see that I have created a critical section class which will be accessing the critical section. So I have defined the pthread mutex underscore t. This is the variable name, object name. So this is the object of mutex object. So you have multiple kinds of mutex objects are there. So here I have taken pthread mutex underscore t. This is the object you have to create, and it has lock and unlock function. So once you lock, it will be locked for that process, for that thread. So here you have to first initialize. So constructor I have initialized the mutex init I did. Then I have two different functions, lock and unlock. So this is the class. I will be calling the lock function to lock the critical section and unlock function to unlock the critical section. And once the process exits, it will destroy that critical section. So these are the destructor functions. So here, I have imported the, I have included the header file critical section.h, and here I have created the critical section variable. So now let's see an example how this critical section will lock the resource. So here I have defined a global critical section object. So I will just call the lock function to lock the resource and unlock function to unlock the resource. Now I am not doing anything. Just I am showing you an example. Here you just go through this thread function first to understand how these threads are created. So it's just a continuation of my previous video. So to understood the thread. So now once the thread, so here I am creating multiple threads. Thread 1, thread 2, thread 3, all these are multiple threads. Pthread create, I am doing multiple thread creation. So now without, so all these threads are calling a common function print thread. So all this function, all this thread will execute this part of the code. So once the thread will be created, all will be executing this part of the code. So it will, what it will do, it will insert a record and delete a record, remove the same record. Now while doing this, now if I have started five threads will at a time try to, when it will try to access, remove the same, remove the call record five times, call record five. i- it's possible that multiple threads will go to the critical section, acquire the critical section. So once it will acquire the critical section, the function will crash. So, so here I am just compiling this. So this critical section object I already created earlier. So here I am creating it again. So I already shown you how this program is built. So you know this object. So here my object is created. Now I am compiling the my test underscore thread dot c, this main function. So here I have L thread. This is a thread library. So this I already discussed in my earlier video. So this is my critical section object, and this is my main function. So I have compiled it. So so my output is created. So let's now. So I have started this function. See, it got crashed. It got segmentation fault here. So why it got segmentation fault here? So what it is doing, I have created five threads with same, which is doing the same activity. It is inserting the record in the queue and deleting the record from the record from the hash map. So what happens is multiple threads trying to insert and multiple threads trying to remove. So once at a time it happens that all threads trying to two or multiple threads are trying to access the critical section at a time. So at that time what happens that it crashes. So this is where is locking is required. Now what I am doing here is I have called my lock function here because I have already created this critical section object in above example. So go to my critical section object. So this is what I have imported from my critical section CPP, and I have created an object of my critical section. So you already seen inside that critical section.cpp, I have two functions, lock and unlock. So what I am doing here, this is my every thread while accessing thread will access. I am just locking that object and locking that this critical section. So once one thread will lock, another thread will not be able to acquire that lock. So this is where my locking is done. So one thread will access, it will insert the record, it will remove the record, then another thread will access and remove the record, insert and remove the record. So let's see how it works. So I am recompiling this, the changes that I did just now. So friends, here you can see that after implementing the critical section, my source got executed without crash because here it has locked the resources. Uh, because here it logged the resources and it allowed only one thread to access this resource at a time. This is how the critical section locking is done. So now this is the example here. So how the critical section locks uh, how this mutex locks a critical section. So here let's move to the next section. So here the semaphore. I am not going to discuss the semaphore in details with example today. So just for understanding purpose, semaphore is used for where multiple threads can acquire the lock. So here one in case of mutex, it one thread acquires the lock and it can only release the lock, but here multiple threads semaphore allows multiple threads to access the lock, and this lock is released using a signal like one thread can send signal to another thread to release the resources. So here multiple threads can acquire the lock based on the count. So this is the difference between semaphore and mutex. So I will be discussing the semaphore in details in another video with example. So here this is what is semaphore and mutex. Now let's see friends, here the singleton. What is the problem with the source that I have shown here? So this is one global critical section, global object I have created, which is not actually completely correct. So what you have to do is while locking the object, you have to define per thread. You have to define a local object, and using that local object, you have to lock these variables. So how you can uh, achieve this local class object, and then you will do the locking and unlocking. So this is a pure example where you will be doing a object. So here it is different, the implementation is different here. So here you can see here the I have created a critical section. Here I have a constructor which will give you the object, but this is not a thread safe because multiple threads try to get the object, multiple objects will get created. So to make it thread safe, there is a way to make it thread safe is to create a singleton, use the singleton design pattern while creating the class. So here is a example of singleton design pattern. This also I will be describing in another video. While I will create a singleton design pattern and I will create another, local objects, local mutex object, and I will be locking that. This I will show in another video, but the correct way of doing this is to create a singleton class instead of creating a global class like this, where when you access, when you create a constructor, it will create a different objects. So there you made a singleton class. So this singleton class, what it will make sure is that this architecture itself defines that when you create a object, it will provide you a single object always. Make sure that the single object is provided. So when you do a lock or unlock, the single object will be used for locking and unlocking purposes. So this is the way singleton works. So this C++ implementation of class will be a singleton class. So how the singleton works and how the singleton design pattern is done. Just see an example here. Here instead of creating the object like the way I have shown, here I have created a global object. Instead of that, what it will do is it will implement like this. It will not just call the constructor. It will call the singleton get instance function, which will make sure that the one object of this class is always created. So if you call it from multiple threads also, it always returns you the single object that is already existing. So first time when you call this function, it will create an object, and it whenever any thread will be accessing calling this get instance will get the first created object only. So if you create a global or local object, it doesn't matter, but you will get always a single object here. So this will make sure that the locking and unlocking is done properly. So single object is doing the locking and unlocking. So this is how you can uh, make the locking mutex completely thread safe. So this is how the thread safe is done. So friends, this is what about mutex and semaphore. So let's discuss about the deadlock. What is deadlock? When two threads trying to lock a single object, then the deadlock happens. You have heard about the deadlock happens. So once the deadlock happens, it just stucks there. So here I can show you an example. Here I have done the critical section lock, and then I have did an insert delete and I have unlocked. So once a thread acquires this lock, it has to unlock this object. So here my code is always doing this. It's locking the object and unlocking the object. So every thread. So I have created 5 threads for the same function. So 5 threads, once it lock, another thread cannot acquire the same lock. So it has to wait. So once it unlocks, next thread acquires the lock and it's unlocked. So this is synchronous. Now if I will do double lock here, so which is called a deadlock. Like while I am calling this function insert call record or remove call record, if I will let's show here a small example. So here I have a remove call function. So what I am doing is I am just uh, doing double lock here. So what happens? Let's see. So I am recompiling this function, this program. Now I do, it got stuck. What happened in the program is, so here what happened is, this thread, whichever thread acquires the lock, it inserts the record, then it goes to remove call record function. and here again it locks itself, locks the same object. So here it got stuck. It falls into the deadlock. So this is how the deadlock happens. So the same object, this is one object, this one object I cannot lock twice. So while programming the critical section, while doing the mutex locking, need to be very careful that you don't lock this object twice. So once you acquire the lock, it must be unlocked by the same thread. Then, uh, then another thread can acquire the lock and unlock. So this is what is called deadlock. So friends, this is all about mutex, thread mutex, and critical section and synchronization plus deadlock. So. So if you like this video, don't forget to subscribe to my channel and like, share these videos. So here I have uploaded more videos related to C, C++. You can view others videos as well, and there are many more other videos related to C, VoIP, RTP plus SS7 protocol and OpenCFs and related to CP traffic testing, all this. So if you and SMS, SMSC and WebRTC related videos I have uploaded. So friends, if you are interested, you can view these videos as well. And if you like this video, please don't forget to subscribe here. If I will upload new video, you will get notification in your YouTube. Uh, so so friends, thanks for watching this video.